Yeah, hello, my name is Kim Hindart and I'm Chief Security Officer at City Network. So some of you might have heard me talk a bit before. So lo and behold, for once, I'm not going to talk about OpenStack. I'm not going to talk about containers. I am not going to talk about GDPR, which is also usually a very common thing for me. So for once, I'm trying to talk about something else, and I'm not going to talk about beer, so, well, that leaves a few options. I do, however, think I will talk a bit about cloud. I will try to keep this a bit agnostic, so before you all say, okay, nothing left for me to listen to here today, so I go home. If you look at the old cloud, we had virtual machines for virtualizing computers on physical hardware, but we had a lot of physical stuff combined with this. So strict machine virtualization has been around for a long time, to say the least, by now. This is, of course, not optimal because you want to virtualize everything. Machines, networking, routers, firewalling, everything. Because if your entire data center, your entire basic infrastructure is programmable, then you can go the route where you can program everything from the basic starting setup of your infrastructure to the end of your application, whatever you need. You can have everything from an infrastructure concept programmed. Then it's code. Of course, one small thing. I talked to a customer late as yesterday who still did not understand that you need to have something physical in the backend for a cloud. No, we have sent our data to the cloud. Which cloud? The cloud. And then look a bit further, and it's sure, of course. And I agree to Microsoft. They did a terrific marketing thing and calling themselves the cloud, the one and only, of course. So yeah, they sent up and said, yeah, but it's still stored somewhere physical. You cannot have anything digital without these three components. You need them. Otherwise, your applications, your stuff won't work. Even if you go serverless, it's still a matter of abstraction of these three basic principles. You need the compute power, you need networking, you need the storage. Then there is a whole slew of stuff behind it you can do, and then we talk about different cloud options. But in the end, someone will need to provide the physical abstraction, the physical capacity to run your digital applications on. If you can, however, program how this is handled, you have come a long way. I would like to talk a bit about then how would you approach this, a bit of holistic security perspective. If you look at this question, why should you wear a seatbelt when you travel in a car? The most common answer, the by far most common answer, to a wronging 80% of the first answer people in Sweden answered. If the police sees me without a seatbelt, I get fined. This is the by far most common top answer to that question in Sweden. The Finnish had this answer: I don't want to be injured or die if I'm in an accident. This is the same approach you can have to infrastructure security, to cloud security. One is rule-based, one is culture-based. Just to be perfectly clear right now, in order to survive the digitalization, in order to survive as innovative companies, in order to be competitive, you need to go cloud. No question about it. That's the truth of things. You need to go cloud. And in order to do that in a sensible manner, you need to establish a security culture. You need to have the base culture of security. Because like I tell my people at City Network, why do you follow this IT policy? Because angry Korean will come and scream and beat me if I don't. That's a perfectly acceptable answer, the same as police gives me a fine. Both answers are true, but the genuine answer is, I don't want to injure other people. I don't want to get injured if I'm in an accident. This is something that's the important part, because if we look at the holistic approach to security, the hardware itself is just small components, but then you need to surround it with this governance, because you cannot avoid any of these parts moving ahead. You will either be beaten down by regulatory demands, you will be beaten down by customer expectations, or you will be beaten down just because you cannot provide an innovative service or trustworthy service. So digital information, your applications, they are very much essential. I will not nag you about all of these security goals. They are all very important, but that's for other shows. Luckily, there is one way you can absolutely survive this in a sensible manner. It's not that hard. The solution is automation. That's why you need a fully programmable infrastructure, because then you can automate everything from the basic data center to the firewalling to the application layers. Everything from start to end from an infrastructure perspective, you can automate. Now, I'm supposed to be a bit vendor neutral, but heck no, I've stopped that. Use Ansible. You have stuff like Puppet, Chef, and Salt, but no, use Ansible. Ansible is the most sensible automation tool out there today. It uses SSH or normal key login, so it uses the basics, so it's agentless. It uses YAML for writing playbooks that you run on Ansible, so it's humanly readable. So I usually say this today, use Ansible. I don't even bother right now to go. If you have a huge deployment of Puppets, yeah, of course, go continue use Puppet, but no, today use Ansible. So, but just to be clear, any automation tool is better than no automation tool. So any automation solution is the basics, because we go back to this. If you can program your entire infrastructure stack, your entire application stack, everything, if everything is programmable, then you can come to this, your code is actually your documentation. This is also very important. You want to have it in this way because you want to use Ansible to launch your infrastructure in a lot of different clouds. If you have things programmable, then you can use multi-vendors, multi-clouds. All of a sudden, you have tremendous resilience, you have tremendous opportunities. You can custom-made and adapt for specific solutions. The big thing to solve all this is, of course, use Ansible in the middle, and then I promote using a GitLab for a code repository. Now you can, of course, switch out GitLab and Ansible for any type of code management and automation tool out there in the market. So just to be clear, every other thing works fine for this as well. Whatever you do, start employing this and using this, because GitLabs, usually people say, but what the heck, GitLab, that's for the developers only. No, it's just as much for operations, because if everything is programmable, then you can use GitLab to build the playbooks that are actually human readable. The nice thing with Ansible is the playbooks are written in YAML, and YAML is a good human readable thing. Back to the goal of your code is actually your documentation. You can then use playbooks for anything, because the nice part with Ansible is Ansible connects to infrastructure capacities with SSH. So anything you could do from a terminal is pretty much something you can write in a playbook and let Ansible do by themselves as well. So there's really no limitation within Ansible. You can configure Linux machines, you can configure switches, you can configure firewalls. Still within the same playbook, within the same Ansible, so you can use it for all things automated. And here is the saving grace for you. Here is where you can save yourself a lot of ache, because then you can deploy things, you can install things, you can configure things. And now I'm talking everything from the bottom of the servers, to the networking, to the firewalls, to the stack, to the application platforms. You can configure your own serverless environment if you want to. You can configure your own container environment if you want to. You can configure, well, yeah, whatever is out there pretty much. You can deploy and use playbooks for security hardening. And the nice part with this is that there's a huge lot of awesome security hardening playbooks out there. I would like to do a big shout out to one specific guy in the OpenStack Foundation. His name is Major Hayden. He writes awesome Ansible hardening playbooks. Go check him out. Now we don't have a running internet here, so sorry for that. I would have shown you otherwise, but go find it. When we publish this video, I will include a link to Major Hayden's really awesome playbooks. He shows you really how to use Ansible to the fullest of the capacity. So that's a really awesome thing. All of a sudden, you get a lot of security hardening stuff for free. You don't need to think about that. Deploy. But you can use Ansible for user provisioning and service provisioning, and even deprovisioning. Because if you imagine, if you have a LDAP for a user catalog, you can all of a sudden decide exactly what users should have access to what service. Directly, automated, configured. So you can have a catalog for roles and users, and then you can just push them to each and every instance, each and every switch, each and every machine. All this that people pay crazy amount of money and spend crazy amount of time manually auditing, following up, reviewing user rights. Why? You have automation tool that provides all this for you. As long as you have a programmable infrastructure. In a physical world where you have people running and connecting physical cables, user access would be tricky, because you can still have physical cables running to the physical console port, connecting stuff, running stuff. Then you need to have other solutions and tools for having auditing and follow-up. But if you have everything programmable, all of a sudden this is stored in a playbook in GitLab. You can have 2 people code reviews. But code reviews is not just for developers now, because ops guys, listen to this. Code review can be a change request. You have GitLab where you have your playbooks. And if you only use playbooks for all configuration you ever need to do, no manual hands-ons on the end infrastructure, hands off, only use playbooks and only do configuration as a code and a code request. Then all of a sudden a fork in GitLab is a change request that can be reviewed by other people. You can even give out to a customer for a code review. So they can have approval process in many steps, in many ways. So a customer can approve what you build in a playbook for configuration. So Git is an awesome tool for it too. That I don't think many would have thought of a couple of years ago. Run playbooks to apply, of course, what you have written, all the security hardening, all the service provisioning, all the installation configuration. But also, in the same manner, you can run playbooks again to ensure that no one is manually tampering and messing around with this stuff. So Ansible works as an awesome application and auditing tool in the same sense. This is some very concrete, very basic stuff. But of course, all this is provided on you have a programmable infrastructure. Luckily for you, there's a lot of different vendors now that provide programmable infrastructure in the end. So whatever you do, don't connect to just one. Connect to all of them. Well, shortly for me, just something I wanted you to think about a bit. Thank you.